What we're doing today is we are moving from confidence intervals, which are saying, based on my sample, what do I expect to see to be true, to hypothesis tests, which say, somebody believes this to be true. Based on your sample, do you support it or not? So the first thing I'm going to ask you guys to do is write all of this down. Okay? Just like we had steps for intervals, we're going to have steps for a hypothesis test. They're very, very similar in what you're going to be writing down. It's just that when that worked wonderfully. When we're doing a hypothesis test, we have a few more things that you're going to need to kind of be aware of. What you see up here are kind of the differences between a hypothesis test and a confidence interval. So a hypothesis test, we still have our P. We're still talking about what is my population parameter, what am I trying to learn about? You want to make sure that you always identify that in context. Today, we're going to be talking mostly about what it means to determine a hypothesis, and then what exactly a p-value represents. We're going to be talking about how to find that next class. So a hypothesis, the nice thing is we have what's called the null hypothesis and the alternative hypothesis. And the null is denoted with an HO, or it's usually a subscript O, and the alternative is an H with a subscript A, ho and ha. That's what some people call it. Sometimes if you go into college, they'll denote this with an H sub 0, because that's the null, that's the no change state, and the alternative is an H sub 1. It's the same thing, depending upon whatever your notation is. And the null for proportions is always written always the exact same way. And that is that P equals some value that you're given. Notice that's not a P hat. For hypothesis, this will always be your parameter. So proportions, that's just P. And the alternative, you're going to be choosing either less than, greater than, or not equal to, and whatever that same number was that you had for the null hypothesis. Then what we're going to do is going to go through the work to find your p-value. Now, your p-value and the interpretation of this is exactly what's written over there, is the probability of getting your sample. Not just the probability of you getting your sample, but if the null hypothesis was true, just by random sampling variability. And just like we had a confidence interval and a confidence level statement when we had to interpret it, that's the interpretation of a p-value. That's the thing. That's another sentence that you're going to have to memorize. Okay? The p-value is probability of getting the sample that we had if the null hypothesis was true. And then what we do is we take that p-value and we compare it to what we call our alpha. And our alpha is our level of significance. It's the saying, okay, as long as I am bigger than this number, I'm going to say it can happen. Like, what's the probability of this happening? If the probability of that happening is 0.5, there's a 50-50 shot of it happening, I'm really not that surprised. Okay? If your p-value is greater than alpha, we're going to fail to reject the null and claim that we don't have enough evidence to support. If p-value is less than alpha, we're going to reject the null, saying we have enough evidence to support. And we're going to go more into what this all means next class. Okay, today we're really talking about the interpretations of all of these things. We're going to be doing the calculations next class. And I think as you saw even with chapter 18, the interpretations were a little bit weirder. The calculations just went. Right? We like the calculations. All right. So the hypotheses themselves. What a hypothesis is, I mean, if you think about it from science, a hypothesis is an educated guess. Right? It's what you're claiming. Our starting hypothesis, the null, is HO. You're going to be given this. Like, you're going to say, I think, or they believe that 90% of students pass the SOL tests. That's what we believe to be true. You're given that. Or it's something that you're going to be able to figure out from your rules of probability. Like, if I flip a coin, I have a 50-50 shot of getting a heads. Or if I'm going to flip a coin 50 times, I can calculate the probability of however many heads that I want. Or if I'm doing a go until, or an out of 50 I have this many heads. I can use my probability rules to calculate that. That's your null. You are not going to be guessing a null. Okay? What you're going to do is you're going to write this always in the form that your parameter is your hypothesized value. And this is very important. The fact that it says parameter there is huge. That means if you write p hat is a statistic. You're wrong. And I promise you, tests, quizzes, and on your AP exam, if you wrote p hat instead of p, you are down from a 4 to a 3 automatically. That little caret on top did that to you. So you want to be very careful with that. And basically what we do is we say, okay, if that's the truth, what's the probability of having my sample? And we're going to just do that using your normal CDF, using your straight up calculations. The alternative hypothesis is kind of along the lines of we think, you know what, my whole thing is I don't think that is true anymore. I think things have changed. My sample says it's not that. So the alternative is what I'm trying to either support and say, hey, this is what really I think it is, or stick with the old. So you are going to be reading through your question for that. They're not going to tell you the alternative hypothesis is that P is greater than this. You're going to have to read through your problem to get your alternative hypothesis. So if I say that I'm looking for evidence that the new medication decreases the rate of infection, then I'm thinking that the new medicine is going to have a probability that's less than. Decreases means less than. So for my alternative, I would write the parameter is less than the null hypothesis. Okay? So actually, this is a lot of words for something that works out to be pretty straightforward. As long as you remember really what's in yellow here. Your null is your HO. Your null is always going to be that your parameter equals your hypothesized value. Your alternative is HA, which you pull from the question. And it's going to be either less than, greater than, or just plain old not equal to. If you're looking for just any sort of a change from what used to be true, then you're looking at it's just not equal to anymore. Maybe it went up, maybe it went down. It's just not the same. Okay, so really those yellow pieces, which you would have kind of gotten from the previous one, are important. Okay? Today we're focusing on the understanding of this, because if you kind of get this part, again, everything we do from here on out is going to follow the same process. It is either going to be a hypothesis test or a confidence interval. Formulas will change a little bit. This is not going to change, which is wonderful. All right, this is from the textbook, so it's not in your notes. But what I want you to do is I want you to read through A, and I want you to write down what you would have for the null and alternative hypothesis. And you have a couple of different choices to do this. You can either use words or you can use symbols. I will show you both. Okay? Go ahead and just write down what you think it would be. Talk to each other what it is that she's asking me to show here. So if we're looking at this, let's talk about the alternative. What do we think the alternative is going to be? We're going to keep the negatives below 30%. What do I want to see? Less than 30. So for this one, it's almost easier to go from the alternative first and then back up to the null. This is the way the textbook writes them, but let me show you the way that I write them. Upside down is a great way to write them. This is the way that I do it because it involves less writing, and I'm always up for the easy way out. There we go. So P is the proportion of the governor's negatives. My null is that it's at 30. My alternative is that the ads get it below that 30%. I like doing it this way simply because if I go back, no matter what, you have to have it in symbol notation. But if I write P equals, I only have to write these words out once instead of twice. Does that make sense what I just did? So if I looked at B and I said, is a coin fair? What am I going to be talking about as my parameter of interest? The proportion of heads to tails. And the thing is here, you really get to choose which one we want. So I'm just going to say P, and I'm going to say the proportion of heads. We know a little bit something about coin flips. If a coin is fair, what do you expect the proportion of heads to be? One more time. 50% or 0.5. So we say P is equal to 0.5. That's supposed to be O. I don't know why I wrote an A. The alternative, if a coin is not fair, then what would P be? Instead of saying less than or greater than, we just say P is not 0.5. Does that make sense, what we're talking about here? And if you don't write out P equals, then you have to write it in sentences, and I don't like that, because I'm lazy. And that's okay. But you have to have this. You have to have P defined either in the sentence or separately. So why don't you guys try C for me? With this, you have to think in context. How would I change what I'm hoping to occur into some sort of an inequality sign? So if sellers of a motivational tape claim listening to the recorded messages can help, what do we want to see happen to that proportion? We want it to increase. Because we're talking about P, at least when I did this, I said, and you can write these guys all sorts of different ways. I chose my P to be the proportion of people who quit smoking. You can put the word successfully in there. Sometimes you quit smoking, you quit smoking. I don't care if you have that word in there or not. But the null is the fact that 20% is what we believe to be true to starting off. My alternative, if it is more successful, I should have a larger percentage of people who quit smoking. Okay? All right, so you can see here, you can write out P once, or you can write the whole sentence twice. I don't know about you, but I know what I like. All right, these are in your notes. And what we're going to do is we're going to keep coming back to this one problem, and we're going to do it over and over again, just talking about the next step of it. So the first thing that we're going to do with this is I want you to read through it, and I want you to identify your null and alternative hypotheses, just like what we just did.